Hello everyone, welcome to this video. In this video, we shall be looking at examples of external direct products. So first of all, here let's consider two groups. One is a group under multiplication modulo 8. So it will consist of all the members which are prime to 8, relatively prime to 8. So they are 1, 3, 5 and 7. Another we have a group under multiplication modulo 10. So it will consist of all the elements which are relatively prime to the number 10. So they are 1, 3, 7 and 9. That we already know. Now using these two groups, we wanted to calculate and write down the external direct product U8 with that of U10, right? This one. It contains how many elements? There are 4 elements in the first group, 4 in the second group. So if we take the first element as 1, then we may have 4 elements. So 1 with 1, 1 with 3, 1 with 7, 1 with 9, right? So we have the elements like this: 1 with 1, 1 with 3, 1 with 7 and 1 with 9. Then if we take 3 here, we have again 4 elements. They are 3 with 1, 3 with 3, 3 with 7, 3 with 9. So these are those 4 elements. Next, if we talk about the element 5 here, we would have again 4 elements: 5 with 1, 5 with 3, 5 with 7, 5 with 9. Right, so 5 with 1, 5 with 3, 5 with 7, 5 with 9. And lastly, if you take 7, again you would have the 4 elements like this. So in total, if you have 4 elements here, 4 elements here, so the total number of elements would be 16, correct? So this is just as the same case that when we talk about the Cartesian product of sets, correct? Now, if this is the direct product. In this direct product, how does the group operation work? Suppose we consider two elements. One is this 3, 7 and one is this 7, 9. Now, how do we apply the group operation here in case of external direct product? So that means we are to calculate 3, 7 and 7, 9. What is it in the direct product? So let's have a look here. For the element 3, 7, 7, 9, what we are trying to do over here, for this element 3 and for this element 7 here, the group operation would be that of the first group, which is U8. And the group operation here is multiplication modulo 8. So that means on the element 3 and 7, we will apply this multiplication modulo 8. And for the element 7 and for the element 9 here, right, these are the elements of U10, right? And the group operation on U10 is multiplication modulo 10. So that means here on 7 and 9 we would have multiplication modulo 10. So what we have to do here in order to solve them, we will firstly multiply 3 with 7. It is 21, right? Because we have multiplication modulo 10. So we'll multiply 3 with 7, 21. And it is modulo 8 in the first case, so it is mod 8 here. In the second case, we'll again multiply because we have multiplication modulo 10. So 7 into 9 is 63 and we have mod 10. Now you know 21 mod 8. When you divide 21 by 8, right, you will have 5 as the remainder. So 5 is the answer for the first term. Similarly, when you divide 63 by 10, you would have 3 as the remainder. So 3 is the answer for the second term. So this is how we perform the computation in these external direct products. So I hope you get a pretty well idea over here. As for the next example, let's consider two groups. Again, the first group is Z2, which consists of two members 0 and 1, right? This is a group under addition modulo 2. And then we have Z3, which consists of 3 elements 0, 1 and 2, right? This is also a group under addition modulo 3. Now for these two groups, we wanted to calculate their direct product. So in the first group here contains 2 elements, the second group contains 3 elements. So in total we would have 6 elements in this direct product. This is one thing. And what would be those 6 elements? Those 6 elements would be 0 with 0, right? 0 with 1, 0 with 2, right? So these 3 elements here. Next, with 1 we have 0, 1 with 1, 1 with 2. So we have these 3 elements as well. So these form the elements of the external direct product. Here the operation is defined in the following manner. So suppose we consider this element 0 and 2 and the element 1 and 1 with us. So here we firstly apply the group operation with respect to the first elements in both the tuples. So therefore we have 0 and 1 with us, and the group operation here would be corresponding to the first group, that is Z2, that is addition modulo 2. So between 0 and 1 we will apply the operation which is addition modulo 2, right? So that means we will add 0 and 1, which is 1, and then we will take their mod. So 1 mod 2 is 1 only. This is our answer. For the second element 2 and 1, we would have the group operation for the second group, which is Z3, and the group operation is addition modulo 3. So between 2 and 1 we have addition modulo 3. So basically we are going to add 2 plus 1, which is 3, and then we will take mod 3 of it. 3 mod 3 is obviously 0, right? When you divide 3 by 3, you would have the remainder as 0, right? So this is how you perform the computation here in this case. So moreover, you can check that this external direct product of Z2 with Z3, this forms an abelian group. So that means every element here commutes with itself. You may check this result yourself, right? So as you saw that, so let me show you one example. We have solved this thing. Now let's solve 1, 1 with 0, 2, right? So it would be 1 addition modulo 2 with 0 for the first element, and 1 addition modulo 3 with 2 for the second element. So what would it be? 0 plus 1 plus 0 is 1 mod 2, right? And then we have 1 plus 2, it is 3 mod 3. So you see we have the same answer with us, 1, 0 as above. So this is for one element. For all other elements we have this commutativity, hence we have this external direct product as an abelian group. So I hope you understood these examples well. Well, that is it for this video. Thank you for watching.